next time. Some definition, just to be okay. I will use the gifted student or gifted child, and I will use the IQ. So we are at this level, okay, in Lygeros scale or Stanford Binet scale or Platter scale. So we are not talking just about smart people. But by the way, everything we are trying to present here will be useful for any people, not just that, but it will be specific for that. So it means that we are talking about 2% of the population, but I will change also, and I will mention severely gifted, so it will be more than this, and hyper severely gifted, more than this. Okay, so here's 2%, here's the rarity 1,000, and here we have 1 million. It's okay. So imagine you have people like this, and they want to study something. So for example, for them, you are teaching a child 10 years old, and in fact is 15 years old. Or more, of course, for this one. So you are talking to him as a child at that level, but in fact it's wrong, it's here. So we have a model. A is talking to B, but in fact we have a mental model of B to A, and a mental model of A to B. So in fact, when A speaks to B, in fact, he speaks to this model. And the answer of B is to this model. So everything is okay when the models are isomorphic. So the problem is when they do not. So the problem is in this case. The first problem is if the master, I will call it master for teacher, for professor, for everything you want, I will just say master, okay? So if you are at a different level, it's not a problem, you choose the master and the disciple. But it will be, of course, for severely gifted and gifted children, gifted students, it's okay. The interconnection between them is a double choice, traditionally. The master chooses a disciple chooses the master. And now we have a problem in education. So this is a choice, in fact a double choice. In education, no choice. Okay? It's a problem. Why? Because we have to detect them. So we are talking about diagnosis. So it's easy. We have many tests. It's good to see also not just IQ, but also EQ, the emotional, and to use also Gardner theory for 8 possibilities. So you have a rather good image of the spectrum of your students. I will consider now a classroom with only those children. Okay, so imagine the first hour with a classroom only with gifted children and students. The first hour will be like this. They will ask you all the questions they have. So you find answer or not. If you don't find the answer, the process stops. So they will consider that you are just a professor. So they don't care. If you answer to all their questions, maybe some puzzle, maybe some smart enigmas, in any case something that they know it, or sometimes they do not know the solution and they want to know the solution. So it's totally different when someone asks you a question knowing the solution, or if there is a good relation between the master and the disciple, you will start to ask questions which have no solution for him or her at that time. So this is a very good point. If you are at this level, you can put a double check. If you are just at this level, just a check. And if you are here, change your classroom. It's not easy to change your brain, so change your classroom. Because you will have problems. So imagine that you don't have problems. Imagine. So, no problem. This means that you answer to all their questions. Now, you have to use a tool, rather strange, joy. And another one, meta-joy. So, meta-joy is the joy which is connected to the joy. So, the master has meta-joy if and only the disciple has joy. So why we use joy? Because in neurosciences, we saw that joy is connected to learning. So in classical education, without neuroscience, we don't care about the joy of the discipline. We care just about the learning system. But, in fact, if there is no joy, no learning, just repetition. The difference between learning and repetition is the following. If you have a classical disciple and you ask him what you will attend as an answer, and he just repeats what you have in mind, you will say, okay. The learning is quite different because he can answer something which is different from your mind. Okay? So just an example. If you have classical students and you just ask, you put this like this, and you say, do you see something special? if I do this, everybody will see it. If I do this, everybody will see it. Try this simple test. It's very difficult for a normal brain to see instantaneously the two right corners. So who cares? If I show you this, you will say it's equal, no? Yes, you should take a picture. It's a good point, because it's difficult, I will not draw everything. And I mean, if I put it like this, it's important to have the same or not. You see, it's not exactly the same. You can see it, it's okay? Of course, we are gifted. No? That's the point. For someone normal, it's almost the same. For the realization, it will be wrong. It's not the same. It's not the same. But in fact, it's not the same with the same way from the other. So there is a little difference. So a normal person will say, oh, who cares? And for the others, they say, why there is a small difference? Okay? Difficult? That's okay. So we are going to use it. We have 5 pieces. Okay? Or maybe you don't see everything. Sorry. If you do not understand what I mean, it's just because it's outside. No? So if you use these 5 pieces, you have to make a square. Okay. At the end of the process, I remove this one, and you have to make a square with a 4. So the specialist of pangram maybe can see it. For the others, more difficult. So I will not show you the solution, of course. But imagine that you return at your home and you say, you know, was it the master at the university and asked us to solve a problem. So they will say, which problem? Oh, it was with 5 pieces. For a normal person, 5 pieces is ridiculous. But after that, if you give the 5 pieces to the normal person, it will have a problem. No solution. So now your brain is already trying to solve the problem, you know? Now, some of you do not accept that it's possible, and the others are trying. Because I have the pieces here, you cannot test what you are trying. So you have a loop. If I give you the pieces, you will break the loop. And you will start to try. Now, if it is too easy, who thinks it's very easy? No one? Easy? Okay. Difficult? Really difficult?
Maybe not sure.
I mean, you see, we have the estimation. It's a very important process. So I will give you an example. I will give you 5 minutes here in this room. Even if you don't want it, for me now, you are a gifted student. It's okay? no choice for you. You are inside, we are like this. So I'm trying to explain you in the lecture the learning system of the learning system. So there is an auto-reference. So if you don't accept it, you have to move. If you accept it, you have to think twice. Why? I will give you 5 minutes okay, to what? To tell me if you can solve it in 2 minutes. Okay, so you have 5 minutes for your reflection, and at the end you will have 2 minutes to do it. So normally you will say it's impossible to have more time than doing this. But in fact, it's a very good process. Why? Because for gifted children, when they see something, they decide it before. If it is too easy, they don't care. If it is easy, they don't want. If it is difficult, they start to like it. If it is very difficult, they will love it. Okay, so do you love it? Oh, yes, yes. So you have a kinetic, you see? So, you know, the person who are trying now to do this, okay, are kinetic people. The person who are acoustics, they don't care what I say, what I show. The person who are optical, they just say that. It's okay. Or not. So, I have one kinetic person, yes, her, next to the cricket, and the others seems to be or acoustic or optical. The estimation. So imagine for each problem you have more time for reflection than time for resolution. So imagine it's free, okay? I will show you now another problem, and I will ask you if you want 2 minutes to solve it, if you want 5 minutes to solve it, if you want your life to solve it, if you don't have enough life to solve it. Okay? Are you ready? Simply be ready. So I will put 4 pieces which are definitely the same. Yes. For those who know Greeks, it looks like lambda, or you don't care. Does not help. Okay, so you see this? You see this? You see the difference? It's very important for your information. This is rather easy. This is rather more difficult than easy. Okay? It's normal. So I want to put the 4 pieces inside without overlapping. So this is correct, this is wrong. It's okay, this is wrong. So I want to put inside the 4 pieces. It's okay for everybody? So the problem is the following. This is non-plastic, non, and non. So the plasticity is your brain. very big difference. So we have plasticity in our brain at the biological level, but we have less plasticity at the mental level. What does it mean? You remember think out of the box, okay? Everybody says think out the box, and of course everybody thinks in the box. Because you just know how to see the box. If you show me the box, and I say think out of the box, you can see it. And you can say this box or this one. So it's done as a puzzle to have the same size, you see, outside, different inside. So in this puzzle, you have to work with your brain outside of the box, which is inside, and not outside. It's okay? You're still with me? Okay. I have a long trip for you. So stay with me at least 1 hour. By the way, I'm always like this, so don't worry. Huh? Not especially for you. So imagine you want how many minutes on this side? So we'll do it easily. You want this? You want this? Yes, fine, okay. You want this? This is 10. Okay. And the others don't care. Oh, 5. You want 5 minutes for that. Okay. And for this one, 2 minutes. Yes, good choice. No. Some of you are very plastic. They do this. You can do also this. Okay. 5 is a good choice. 5 is not a good choice. On average, for this level, okay? For the normal level, there is no choice. So we don't care. But this is rather difficult. And the fact is, you say, your choice was made by this, no? Try to be with your brain and more plasticity. You choose a different time just from this. No? Did you try to avoid? So now I remove this, forget it, and I say, just this, just see this. And now again I say, you need 2 minutes, 5 minutes, or 10. You just see that. You don't know the box. So you can tell me that it's more difficult to estimate. But in fact, you are going to solve the problem out of the box. So if you solve it out of the box, you don't care how the box is. But your previous estimation was due to the box. Okay? So there is something which is difficult, is at the end I will give you, try it, don't worry. And if you don't want to go, I will shut down the lights, it's okay. So plasticity at the mental level is very difficult. Why? Because plasticity is not adaptation. Totally different. I adopt another behavior because I can do it, okay? So I see something and I avoid something. So we are talking about obstruction. For example, I have one obstruction here to take all this kind of thing in 1 hour. and I estimated that it's rather impossible, but never mind. So I will stop in 1 hour. The obstruction is a clue. Explain. If I give you this, like this, and I ask you, try to put them in the most compact way, okay? Without overlapping. You don't care about this. But if I show you this, you will use it. So, this is a problem? No? In fact, no, this is the obstruction. And the obstruction is a clue for the resolution of the problem. This is a problem. I put now an obstruction. Okay? But with the obstruction, the problem is easy. Why? Instead of that. Because now you know the size of the box. So you can use it. You can do something like this. Okay. You see? You can try. If you don't have the size and you don't have the shape, then you can't try. Okay? So, another example. This is a cube. I mean, you see it's a cube. No. So the small pieces are these little cubes. How many cubes you have here? It's easy. 1, 2, 3, 1, 2, 3. So 27. Okay? But you don't know how the pieces are. So now I do this. And I ask you again, how many minutes you want to solve it? Because you saw the solution, so it's possible, okay? Oh, don't say that. No, no, no. You can do it with that. Yes, it's possible, it's possible. So now, let's try to see it, how it's possible. For example, you have 4 pieces, it's okay? 4 pieces. 4 pieces. You see, when I say 4 pieces, I mean the cubes, okay? So, I have 7 pieces. So, every piece has 4 cubes or not. Of course not. Because you will get a perfect number, 28, but not a cubic number, 27. So this is easy. That's the explanation. Maybe this one is a little bit difficult, you can see it. Okay, and also this one. If you try to analyze this as a gifted person, you will say this is 2-dimensional, and also this one. This is 3-dimensional, really. Of course, this is one is also 3-dimensional, but in fact it's a projection. So this is difficult, difficult, difficult. This is the reflection of the other one. This is easy, easy, easy. So you have to find an equilibrium between difficult, easy, difficult, easy, difficult, easy, easy. Normally, now it's more easy. Okay? The fact that we have this as a mirror, this is a clue. Yes, it's a clue. Okay. This is a corner. This is also a clue. So, it was mention about the obstruction. We have two obstruction, we have two clues, and we can start the process. So now you are going to see something which is rather strange. Do you see this one? This is not a cube. As Margaret said, this is not a pipe. So this is not a cube. Yeah? You agree? So, don't worry about the picture. I will put it in a better way. So now I put the other pieces. So now my question is, the parallel pin or the cube, which of them is the more difficult? And I will show you a little detail. So imagine that you see this one. In fact, this one is the same or not with this one. It's okay. Same. Your brain is going to do this. So, same, and same, and again, same and same. Can you consider that this is a difficult piece? No. This one? No. This one? No. But one of the three is important. A, B, C. Who prefers A as an important? Who prefers? No, it's not the time. Don't say time. It's just one. She's obsessed by the time. Okay. Who prefers B? Who prefers C? Okay. So we vote for B. Why? Because it's impossible to put this in a cube. 4. You see? So this one belongs certainly to the other. So this is not a cube. For this one is difficult. We saw it as a cube. This one is strange. What I want to show you is the brain has to consider that if you take this one, which is more complex than this one, and more complex than this one, we agree? Yes. But the combination of two simple things creates a more complex object than this one. So the resolution of the 442 will be more difficult than the resolution of the 333. We agree? Yes. You said that. It's okay. So, just to show you, if I put this like this, and now I consider that this is a piece. This one is more complex than this one, no? So, for gifted student, to see this, and this, they will start to say, can I combine this? For example. Can I combine this? So, now for the computational gifted. We have a 3, 3, 3 and a 4, 4, 2. We have 7 pieces, and we have how many pieces here? You don't remember? Of course you remember.
8.
Yes, why? don't care. You just remember 7, and you know that it's plus 1. No? Imagine if there were 7 million pieces, and I just set the difference in 1. You will find the number. So, with this and this, you have already something. Each of the A should be 4, 4, 2, so in fact 32, 8, 4. For this one we have a problem, so 6, 4 plus 1, 3. We agree? It's only for computational gifted students. If you are not in this case, you don't care. You said, okay, I will try again. But I would just want to show you that for gifted students, if they are computational gifted students, they will say everything like this automatically. So they will say, it's impossible to have this one. And you will say, but how do you know this? You did not try it. Because I can do another game. I can put everything here. Which is, of course, more complex. And it's better for gifted children. Now I say, how many minutes do you want? Oh, you know. How many minutes you want to find the two objects? So, do you realize that we have 3 problems and not 2 now? We agree? Why? Because you have to find which is a part of what. So, it's very important. When you have 2 problems, you have 1 link. When you have 3 problems, you have 3 links. When you have 4 problems,
6.
of course, 6. Very good. So, in a more mathematical way, this is K2, this is K3, and this is K4. K is for Kuratowski. If you don't like the name, you don't care about Kuratowski. Okay. So with 5, how many links? CPU, GPU,
9.
TPU.
9.
Okay, again. So imagine that you are optical. Some of them need that. Some of you, except the girl there, which is cinetic. The others, you can see that you see that? Yes. Mathematical, C5 plus C5 equal K5. So the order is 10. It's okay? So in fact, I just want to show you something. When I ask you 2 problems, and I put all the pieces together, we have the problem of the partition. First problem. This this problem, in fact, can be more complex than the others. Why? Because the partition is free. This is fixed. This is fixed. But you don't know how it is fixed. So you have a free problem. For the brain, freedom is a problem. It's rather strange, huh? Especially in neurosciences and in fact in math. Because freedom, you have the choice. And when you have the choice, you have the problem of the choice. No? You agree? You can see the rules. When everything is straight line, you don't have many things to explain you something. If there is a bifurcation, go there or there. If there is something more complex, wrong, do that, that. So, this is easy, this is complex, this is very complex. So they will explain you there, nothing, here, right, left. I just saw in, at the airport, they say, stay left. I thought that it was for us, because we stay right. So it's very strange, because when you go to Europe, except for United Kingdom, they don't say stay right. They should. There are less people left than right. How many people, is there anyone who is left hand? Yes? A good left one, because you say it like this. If you say it like this, it's wrong. So, in fact, we have 70%. I don't mention anything about sex. Do you want something about sex or not? Or you don't care?
Why not?
You don't care. Why not? Okay, so about sex. I made a difference. Is there really any difference? Do you want a difference? Or you don't want a difference? You don't know what you want. It's important. Why? You know, left hand and right hand. You can say it's obvious, but it's equal. It's not equal for the brain. It's important. Okay? So, you can see it in some games. If you use this, it's very important. It's very important at two levels. There are few, there are many. So the many plays many times with many. And rarely plays with left. But the left plays many times with the right. So, for the left to play with the right is a normal situation. For the right to play with the right is a normal situation. For the right to play with the left is a rare situation. And the very rare situation is this one. But if you're not in this case, you don't care. Now, the distribution. Because you avoid to mention the sex, I will not show you what I mean exactly, but you have to define it. You see distribution. You know this guy. If you don't like names, you don't care. The important thing is that there is a difference. So, for example, for 4 sigma, the difference is 1/7. 4 sigma is 164 in IQ. The difference is symmetrical. Okay, so I just mentioned it. If you have a question, we'll answer. So, obstruction are clues and the starting point of resolution. I don't mention until now problem of memory. So memory is in fact related to intelligence and with a positive correlation. But it's not so obvious. Why? Because memory